We will try to learn all these concepts by re-implementing some popular NgRx APIs. If we try to type users feature.users, you can see the name is users, so it correctly inferred it took this string literal name here and returned it as a type. When functional true is passed here, we want to return the effect factor itself with applied metadata, and when functional is set to false, or if we exclude our config object, we want to return the observable, the effect factor result. Another very interesting thing here, the create action group will automatically create a type for our action, but by applying source event pattern. Today I'm going to talk about advanced TypeScript. We'll learn more about generics, about conditional and recursive types, about function overloading, and more. And we will try to learn all these concepts by re-implementing some popular NgRx APIs. And the first API that we'll try to re-implement is create feature. I created this feature, it's almost about 2 years ago, something like that. And it's primarily used to reduce the repetitive code that we had in our selectors file. So let me quickly show you what this function does if you're not familiar with that. So we can create a custom NgRx feature. Let's call it users feature, for example. So I'll create a constant users feature, and then I'll call it create feature function and import it from the NgRx store package. This function accepts a config object with two required properties. The first property is a feature name. So we can say, for example, name, this feature is users. And the second is feature reducer. So if I pass the reducer here, we can directly call create reducer. And for example, pass here and say that we want to have selected user, which is type of, let's say it's initially null, and it can be string or null as a type. Besides that, I also want to specify that we have, for example, list of users. So we can say it's an empty and it's type of strings. We can define a type but for user, but it's not really important in this example. So when we pass the feature name, we pass the feature reducer. As a result, we will get the object that contains the following things. So if we try to use auto-completion, you can see that users feature will contain the reducer and it will contain the feature name that we passed as an input argument. But create feature will also generate selectors for us. It will generate the feature selector. So with name select user state, as you can see here. So this object will contain a feature selector and selector for each feature state property. In this case, we have selected user and list of users as feature state properties. So it will generate select users and select selected user. And everything is strongly typed, of course. If we, let me say, const result is equal. So here you can see that type of select user selector is memory selector. This is the type of record string and is the type of the global state. And as a result, you can see that we have string or null, which is exactly what we specified here. Okay, let's now try to re-implement this function. And we will not focus on the implementation, but only on types. So I will create a new function and I will call it my create feature. I will use declare because, as I said, we'll just focus on type. Declare function my create feature. And as we saw here, this function accepts a config object with two required properties. The first property is name, which is type of string. And the second property should be reducer. We will start by passing only the initial state to simplify this function initially, and then we will back to reducer. So I will say initial state, and let's put any in the beginning like this. And as a result, I will return an empty object for now. Let's now try to call this function. So if I say const, or we can replace it directly here. My create feature, and instead of reducer, I will add state here, initial state, which is this. So if we inspect the type, you can see that it's an empty object. If we inspect the input argument, you see that the name is type of string, initial state is type of any. In order to be able to define the strongly typed keys, so to define keys for selectors and string literals, we need to use generics here. We need to infer the name as a string literal, not as a string. And the same is for initial state. We need to infer the exact type that is passed here. So to do that, I will use generics here, and we can say that we'll have two generics. First is name that extends string, and the second one will be state. So then we can say that name is type of name generic and initial state is type of state generic. If we check how it looks right now, you can see that our input argument is now correctly, type of our input argument is correctly inferred. The type of name is users, so it's not a string, but it's a string literal users. That's exactly what we need in order to be able to define select users state property. And also for the initial state, you can see that it's correctly inferred. So now it's time to try to find a way how we can define a result. And as we saw, users feature should return a feature selector and selector for each feature state property. Let's first try to define feature selector. So here we can, in order to get this name string literal, we can do something like this: key in name. And then as a result, I want to say that this is type of memoized selector that has object as a global state type, and as a result, it has state. In other words, it has a feature state as a result. Now, if we try to type users feature.users, you can see the name is users, so it correctly inferred. It took this string literal name here and returned it as a type. And we can see that now we have type of this is memoized selector that has our state as a result. But we don't want our feature selector to have name users. We want to have select prefix and state suffix, right? And to do that, we need to change our type definition here. So here we can say something like this. We can say as, and then define a type for this property as a template literal. So I want to say select as a prefix, then I can add key here. So this is a type, this is our name. And after that, I want to add a state suffix. If we now inspect the users feature, you can see that we have select users state here. The last step that we want to do is to capitalize this property name. So we can do that here. We can say capitalize key like this. Yeah, capitalize keys. By the way, this is built-in TypeScript type. We don't need to define this by ourselves. So as we have, I don't know, omit, exclude, pick, and all other utilities that TypeScript provides, it also provides this capitalize utility type that works with string literals. So now if we type dot, you can see that now we have select user state name, which is strongly typed. And this is exactly what we want to achieve. The next step is to define the type for selector for each feature state property. And here we can add intersection. And as a part of this second object, we can define selector for each feature state property. So what we can do, we can say key in key of state. We want to walk through each key from this state object, right? And then as a result, I want to return memoized selector that contains object that has object as a global state type and state of key as a result. The last step here is to add select prefix and to capitalize the key. So we can do similar, in a similar way here, we can say as select capitalize key. And now you will see the compilation error here, because potentially key can be string or number or symbol. But capitalize expects a string, so we need to cast this, and we can say and string like this. Let's now see what we got here. So if I say users feature dot, you can see that we now have three selectors. We have select selected user and select users, which are selected for feature state properties, and we also have select user state, which is a feature selector. So that's actually how types. This is a simplified version of how create feature types work. The last step was to replace this initial state with reducer. So what we can do, instead of passing initial state, we can say reducer, and here use action. I think it's called action reducer type. And now instead of initial state, we can say reducer and use create reducer function that returns action reducer. But we are not interested in reducer, exact type of reducer. We are interested only in state in order to make selectors for feature state properties, so we can directly use state generic here. Okay, this was the first function that I wanted to show you. The next was create effect. And some time ago we introduced, I'm not sure if you are aware, but we introduced a new way of defining effects. We call them functional effects because now we don't need to create classes in order to define NgRx effects. But there was one problem when we were considering to introduce this feature. The problem was that if we want to keep a way of creating effects by using create effect function, we cannot use the existing signature and don't have breaking changes actually. So the trick was to introduce additional config object as a part of the create effect function input argument that will make this differentiation. So we will be able to differentiate functional effects from normal or let's say class-based effects. So let me show you. If we say constant my effect equal to create effect, and create effect accepts effect factory as an input argument. So here as a result we need to return observable that returns an action. I will define some dummy action, so I'd say const a equal to create action a like this, and then we can return off a here as a result. Yeah, we need to execute this because this is the action creator, not the action. So here, if we inspect the type of my create effect, you can see that type is observable, and it contains this typed action A, and also there is an intersection with create effect metadata because create effect will add some additional properties to our observable. So on the other hand, this is for class-based effects, but for functional effects, they are defined by using functional true flag. And let's now inspect the type of this effect. As you can see, the type now changed. The type is functional effect. So now, instead of returning an observable, the create effect function will return the effect factory itself with applied effect metadata. We needed this behavior because when we define functional effects, we didn't want to execute this callback immediately. Instead, it needs to be executed when effects are registered. So that's the reason why we need to return effect factory instead of effect factory result or observable. So to achieve this behavior, as you can see, based on this flag, if I say functional false here, now we will again have observable as a return type, not the function anymore. To achieve this behavior, we need to use function overloading. And I will first show you how function overloading works on a simple example. So let's try to define add function. Add function that has two signatures. One signature some can accept numbers and another signature accepts strings. So to have everything strongly typed, we need to define two signatures for the add function. First one will be with element which is type of number, let's say element 1, and element 2, which is also type of number, and the result will be number. And the second signature will be with strings, like this. So now if I call it, I say const result is equal to add 1 and 2, the type of result will be number, as you can see, because it will point to the first signature of add function. But if I call it with two strings, then the result will be string. It will now point to the second signature. And this is exactly what we want to achieve with create effect function. When functional true is passed here, we want to return the effect factory itself with applied metadata. And when functional is set to false, or if we exclude our config object, we want to return the observable, the effect factory result. Let's now try to create my create effect function. So I will declare a new function. I'll call it my create effect. And this function accepts effect factory as an input argument, right? And the type of this effect factory is a function that should return observable. And this observable should be an action like this. Yeah, I want to import action from the NgRx store. And the result will be observable of action and create effect metadata, but we can leave it like this for now to simplify it. So now if I replace this create effect with my create effect, let's see. Yeah, the type you can see now will be observable of action. If I want to have strongly typed my create effect function, in other words, if I want to return the exact action type that is passed here as a result, I need to introduce generic. So we can say a extends action like this, and then we can pass a here and here. So now the type of my effect, as you can see, will be observable typed action a instead of just action. And the second part is to implement another signature that doesn't return observable, but returns the effect factory itself. But this, we need to point to this second signature only when functional true config is passed as a second input argument of my create function. So I will copy this. And as a second signature, I want to have different set of arguments, of input arguments. I want to say config here, and I want to have functional true, like this. So now, also, instead of returning observable a, I want to return effect factory itself. So now what we will do, we will define the generic for effect factory. We'll say effect factory that needs to extend a function that returns observable action, like this. So now we can here say this is type of effect factory. And as a result, I want to return effect factory. For the first signature, I also want to point to the first signature when functional is false or when config object is not passed. So to achieve this behavior, we can say for the first signature that it has config as an optional input argument, and if it's passed, functional needs to be false, like this. So now if we check here, you can see that we still point to the first signature. If I pass functional false here, we will get the same result. But if I change functional true, we will now point, you also can see that my ID is able to recognize that. We will now point to the second signature that returns the effect factory itself. So this is how function overloading works. And the last example that I want to show you, probably the most interesting one, is how we created, how we made create action group function. Maybe you heard about it. So we use create action group to define a group of actions, a group of action creators actually with the same source. We can say users API actions equal to create action group. Create action group accepts a config object with two required properties. The first is source, and source in this case will be users API, and the second one will be a dictionary of events. First event will be, for example, user created success. This will be the event name, and this action should be dispatched, for example, from user API effects when user is successfully created. And here is a value I want to define what is the payload of user created success action. And for that, we can use props function from the NgRx store package and pass here as an input generic argument. We can pass what's the type of payload for user created success action. So we can say, for example, user, which is type of string, like this. And I also want to define a second action. It will be user created failure. And it will have error message, that is type of string. Now let's inspect the result of users API of create action group function. So we will check what user API actions object now contains. So if we say users API actions dot, you can see that we now have users created failure and user created success action creators. For user created success action, we need, everything is of course strongly typed. We need to pass the user, which is type of string. If we inspect the type here, you can see that result is a typed action, and you can see another very interesting thing here. The create action group will automatically create the type for our action, but by applying source event pattern. So instead of the square brackets, it will take source string literal and put it there, and after that, it will also take the event string literal event name and put it as a event name for our action. So let's now try to create this function. Actually, I will say declare function my create action group like this. My create action group will accept config object, config with two properties. The first property will be source, and we need to define two generics here. The first generic will be source that extends string, and the second one will be a dictionary of events. So I can say events extends record. We can say that it extends record string any, because anything can be defined as a type for our payload. And now the type of source will be source, the type of events will be events. If we say this, and let's return something here, if I replace create action group with my create action group, let's now check. Yeah, we can see that our input arguments are correctly inferred. And as a first very important step, now we need to define the return type, the result. So as I told you, we need to return for each defined event here. We need to define the type for action creator that should be generated by the my create action group function. So what we need to do, we need to walk through the keys of events first to define this name for each action creator. We can say key in key of events. Let's first do this. And then as a result, we want to define an action creator that will have a payload, which is type of event, events of key, like this. And as a result, it needs to return action that contains type property plus the type of payload. So we can say it should return an object that contains type, and for type we want to apply source event pattern. So here I can say the type of the type of this type property should be source, like this, and then here we will have our key. And again, the type of key can be potentially, even if we define string here, it can be number or symbol, so we need to cast it and say add string here. So this is the first step, and the second step is to add payload type itself. So we can use intersection and say and events of key. Let's format this, and if we try to replace my create action group, I also want to create my props custom function. This will be a very simple function. Declare function props. It will accept the generic and return a generic, that generic as a result, like this. I will define it, my props, like this. So we can use my create action group, and now here say my props and my props. Okay, let's now inspect the result. So now users API actions, if I said dot, you can see that it now contains these two events that we defined here, but the names of properties are equal to event names. And this is not what we want. What we want to camelize this title case event name. So we want to remove these spaces and we want to uncapitalize the first letter. Let's now see how we can achieve that. So this needs to be done here. And first I will create a helper type and I will call it join. Join should remove all the spaces from the event name. So I will define a type, I will name it join, and join accepts a string as an input argument. So what I want to do here, I first want to check if my string contains space. We can do that in the following way. So we can say string extends, and now I'm asking for a special format here. Infer first, so, and here we can say infer rest. So I want to check if my string extends a string that has a space. And by using this infer keyword, I can get the type of the first, so of the part of this string before the space, and with infer rest, I want to take the type of this string after the space. So if this is true, I want to call join again. So I will recursively call the join type, and instead of passing this string, I want to pass the string without this space. So what we can do here, we can pass something like this. We can say first rest, but as you can see here, there is no space anymore. And if my str doesn't contain any string, any space, then I want to return str itself. Now let's try to use it here. So we can say as join key, right? And cast it to string like this. Let's now inspect the users API actions object. So if I say users API actions dot, you can see that we now have user created failure and user created success action creators. But the last thing that I want to do is to uncapitalize the first letter. So we can use another utility that TypeScript provides. It's called uncapitalize, and the result of join we can pass as an input generic argument to the uncapitalized type. And that's it. It should work right now. So if I say user created success, you can see that type of this is a function that has a payload, which is user string. This is exactly what we defined here. And as a result, we return payload plus we are returning object that contains type property. And you can see that type is properly defined, so it applies. We are applying source event pattern. We are taking the source string literal, users API, and then we are adding the event name user created success. So now to make this work, we need to pass the user string. And that's it. That's everything what I wanted to show you for today. Thank you very much for attention. And if you have any question, feel free to leave it on chat.
Thank you, Marko, for this great talk. It was really impressive to watch how easily you have almost re-implemented the typing behind the NgRx API. And of course, right now we will jump to the Q&A session. But before that, I would like to ask you, what is your most awaited feature of upcoming Angular 17 version?
For me, it's a new application builder that provides server-side rendering, static side generation out of the box.
Okay.
And also hydration improvements. But yeah, control flow is also very interesting, and especially new defer macro. So we will be able to apply lazy loading at a very granular level in a declarative manner, which is great.
Yeah, and there is also one extra thing that they are hiding behind us. So we will see what they have prepared for us. Okay, so jumping directly to the questions, there is first question from Ayman Adventures. Do you think that signals can be replacement for NgRx?
No, I don't think, because signals and NgRx can work very well together. NgRx is also, if we talk about NgRx store, in fact, it's also architectural pattern. It's not only the, I don't know, a replacement for something that Angular doesn't have. Currently, all NgRx packages that we have for state management, NgRx store and NgRx component store, two most popular ones, they have integration with signals. So instead of store.select, you can now use store.select signal, and instead of observable, you will get signal as a result.
Okay.
That's about current existing packages, and we are also currently working on a new package. It's called NgRx Signal Store, and it will provide first-class support for signals. So it's built with signals. It has RxJS as an optional dependency. And yeah, at Angular Belgrade Day, I will give the first talk on Signal Store. If you're interested to hear more about it, you can also register to the NgRome conference in December. I will give the same talk there as well. And I think that NgRome has, so for online attendees, it will be free. So you can register and watch my talk there.
Okay, thank you. There is another question from Jakub. What determines your choice of overloads over conditional types?
Yeah, that's a really good question, because initial version of Create Effect had a lot of conditional typing. I think the situation with types can be much simplified with overloads. And that's actually what I try to achieve with Create Effect function. Instead of using overloads, we could use conditional types for Create Effect. We could have single signature and say, okay, if config is type of functional true, then return effect factory, else return the effect factory result. But I think the situation is much simpler with overloads. So I prefer using overloads when possible.
Okay. There we have a question from Sonic Walk. If I understand, key and string is kind of casting.
Yes, exactly. Because when we are walking through the type, which is an object or record, each key can potentially not be just only a string, but it can be also a number or symbol. So all the TypeScript utilities that work with strings, with string literals, they expect string literal as an input argument. So yeah, you are right. We need to apply some kind of casting.
Okay, and there is probably last question from Jakub. In NgRx lib, do you use prettify? You use many never.
Actually, I don't understand the question, but if you are asking, do we use prettify? Prettify as a library for formatting the code, yeah, we're using it.
Okay, and that was probably the last question. So Marko, you has been highlight of our meetup, and your expertise of demystifying the TypeScript concepts behind NgRx API was truly exceptional. And we hope to welcome you back as a speaker in the future, and see you soon in Belgrade.
Thank you. Looking forward to meet you in person. Have a great evening. Bye-bye.
Bye.